Welcome. My name's Elaine Henry, and I've been given the honor of introducing these two distinguished guests. But first, I'd like to ask you to make sure your cell phones are at least in the silent mode. And another item of housekeeping is that if at the end you have questions, would you please go to the microphone down the center aisle. This is because the presentation is being recorded, and also so everyone can hear the questions. Thank you. Our first presenter will be Anna Calori-Holcomb, professor. She has been working with new technologies for 8 years when she helped establish a Fab Lab at the University of Florida. Her technique has been published in numerous international journals, and Anna is a past president of NCECA, as well as a fellow of the council. And although she doesn't look like a fellow, neither do I, but it's an honor they bestow upon us after so much service. And she's a member of the International Academy of Ceramics. So this is Anna. Our second speaker is Chad Curtis, who is an artist living in Philadelphia. He draws his inspiration from both digital technology on the relationship between human beings and the natural environment. Chad's an associate professor at Tyler School of Art at Temple University. And in a field that's constantly changing, I think we have two individuals here who bring extensive experience to the topic in teaching 3D printing, CNC routing, and laser cutting. So would you please give a warm welcome to Anna Calori-Holcomb and Chad Curtis.
Thank you so much for that wonderful welcome, Elaine. And welcome, everyone. It's really exciting to see the building between this and what's going on in the Fab Lab just across the way here, the use of technologies in the ceramics studio. Those of us incorporating new technologies into the traditional ceramics curriculum often feel like we're traveling in uncharted territory. With new developments almost on a daily basis, there's so few references to refer to, resources that we can have. Any educator must be willing to take risks in this territory. And Chad and I have found many reasons to take these risks, only to see rewards in the unique work that our students do. These technologies are here to stay, whether we choose to use them in our personal creative work or not, and we feel our students should be made aware of and have the experience of using them so that they can make choices about using them. And a rationale that we've adopted with the use of digital fabrication tools in the classroom are many. One of these is that the tools help to provide access or an approach to clay in a much wider range of students than the traditional methods might afford in the ceramics field. As art and design students develop general digital design skills, these are easily transferable to a number of materials, including ceramics. Approaching these tools as, quote, just another tool in the toolbox, unquote, helps demystify ceramics to those from the outside, and it minimizes the novelty for those focusing in ceramics. This opens the door to a broader student base, helps ensure strong enrollments, and provides opportunities for students to collaborate and work across disciplines, which tends to be a curricular trend these days. There are numerous ways that these tools can be implemented in teaching, ranging from use of technology as a philosophical and technical approach to a more fluid and integrated approach alongside traditional studio techniques. I'll show a number of personal examples and projects by other teachers across the U.S. Of course, the elephant in the room is the notion of craft and the hand. Peter Dormer, an important thinker and writer on contemporary craft, wrote in his 1997 book, The Culture of Craft, Status and the Future, in the article titled, Craft and the Turing Test for the Practical Thinker. This chapter is an examination of studio crafts in the context of the machine and computer technology. Computer technology now provides craft with its most serious, philosophical, and practical challenges. He goes on to say, On one hand, our very notion of what is to make, and that's in italics, something is being transformed. On the other, the importance of the hands in making is not thereby removed by computer technology's ability to quote-unquote make everything, for it's conceivable that different kinds of making provide different kinds of understanding. At the University of Florida, there is an interdisciplinary ceramics class I teach for the School of Art and Art History, and it's titled 2D to 3D Surface and Form. And this class is not just ceramics majors, but it has students from all the other studio areas. This course often utilizes ready-mades and mixed media, and so the students do not have to be proficient in clay working. This course begins with tiles and plates to introduce surface techniques, and then moves to 3D scanning and printing, as well as laser cutting and CNC routing. This particular assignment allows for experimentation on both a technical and design level, utilizing pre-manufactured or handmade tiles, plates, and other flat form objects for multi-level imagery. The objects need to work in both a modular and individual basis. I asked them to use at least a minimum of 12 tiles and or plates or other flat format objects, and involve at least two of the following techniques: laser decals, digital decals, transfers, die cutters, stencil laser cutting, etching, sintering, water jet cutting, and for a little bling, China paints and luster. Possible formats can include tile murals, place settings, for example. UF Ceramics has an in-house Enduring Images color decal printer. It's run by one of our graduate assistants, and they're assigned to run some of the technology in our program. Students have an order form to fill out, a fee to pay, an email to send the digital file to, and a couple days later, the decal is ready for them to pick up and use. This machine allows for the inclusion of detailed photographic imagery to the ceramic conversation. I do find that students are often a bit intimidated in using decals, so I schedule occasional workshops, I call them Decalomania, to explore options in decal use, and I try to have available a wide range of them. So besides the digital decals from Enduring Images, we have laser decals that are printed on HP laser printers. Those are the ones that give you the sepia-toned imagery. Color sheet decals from Ceramic Art Cart. These are still experimental. They're not on the market yet, but we've been working with them as sort of an R&D development and share our results with them. Those can actually be put in a die cutter. So we have a Zing, which is a hobbycraft die cutter you could find at Michael's, for example. And then I've also, over the years, collected a lot of Chinese decals, both underglazed and glazed. And then I actually started out doing a lot of decal work by buying ceramic decals off eBay. And so I have a large number of vintage decals. And so students can bring their own work to fire, and then I always have commercial tiles I could pick up at Lowe's, and plates that I can, white plates that I could pick up at the thrift store and have them available so that students can just experiment and play and gain some confidence in the use of the decals. The class then moves from surface to form and starts to use 3D technologies. My personal research continues to rely on the collaboration of an art and technology artist with a focus on more affordable and easier to use software and hardware. 3D scanning is a powerful and accessible way to digitize physical surfaces as 3D models, which can be used to make 3D prints. This is a more object-based approach to working with digital imagery and can easily be interwoven with other methods of modeling. And as a clay person, that idea of it being object-based is very appealing. There are a number of methods of scanning. The process officially is called photogrammetry. And in this process, a digital 3D surface is reconstructed from multiple photographs of a scene or an object taken from various angles and positions. The scanner captures the images at different angles and heights, and then that photogrammetric process requires common points of contrast, and these images are then reconstructed in space, which takes the 2D images and processes them into a 3D file. Here you'll see the use of a Next Engine 3D scanner, and it's just a artichoke from the grocery store, and you'll see the results are quite impressive. The nice thing about the Next Engine is it's stationary. It has its own mechanical turntable, which turns it in a variety of angles as well, and it has its own light source. And this particular one is actually available to us in the library. Also available from the library is a structure. I brought one here just as a show and tell. It goes onto your iPad, and the nice thing about this particular scanner, although the quality is not nearly as good as the Next Engine, is I could take it places, and it will scan images, and you just email them to your email. Here you'll see the quality of the imagery I get from that on the 3D image. Then there's a plastic that, of course, that particular file was manipulated so that the artichoke was opened up to form a bowl form. And then the little one in there is an object resin printer, so it's a high quality resin printer. The white one was just on a MakerBot print, and from that white one then a mold was made, and you can see the subcast porcelain bowl. So the process is a rather it takes many stages, but it is rather a simple one overall. Let me make sure I got the right one here. One back. Okay. It's important that students experience tangible results quickly to keep them interested and engaged, and we all know this, even as artists ourselves. And this means introducing them to software and the fabrication process quickly so they can have a tangible object in just a few weeks. This quick result is a trade-off in the depth of the software skills that are introduced. It's key that the students are able to conceptualize the process of making something in this manner from start to finish and see all the different stages. You can really I can get lost, and I know my students would get lost if I spent too much time with in-depth teaching of the modeling software, and it would be easy to lose interest. So we try to keep a lot of this simple, using freeware such as Autodesk Mesh Mixer. This is a screenshot of their website. Another one that's very handy is NetFab. They're easy to use for the inexperienced and give very quick results. They're particularly good at what we call fixing holes or any defects in the 3D files to prepare them and make them ready for printing. And I love one of the things that they say here on that website is, think of it as a sort of Swiss Army knife for 3D meshes. So the idea is that it's easy to use to fix your files. There's some even more simple software to use. There's Tinkercad, for example. It's part of the Autodesk suite. And this website, there's no need to even download an app for this one. And the quote-unquote website says, easiest way to get started with 3D design online. And it has a look that would appeal to a hobbyist or even a child with a desktop printer that might want to print toys. 123D Sculpt Plus, a little bit more sophisticated. That's a free downloadable app. It works well on an iPad. And then, of course, there's packages that I'm sure you've heard the buzz in the background, things like Maya, Rhino, Blender, CAD/CAM, and SolidWorks, to name just a few. These tend to be expensive. They have a much higher learning curve. But most of them, you'll also find that there's a lot of tutorials out there and a lot of help. So if you're willing to or want to invest a little bit more time in terms of software, then those would be some of the ones to work with. There's Tinkercad and so this particular assignment I used with those 2D, 3D students as well as my advanced students, and I asked them in this particular assignment to find a simple object, either in nature or something manufactured, 3D scan it, typically use the Next Engine with that, and manipulate it in some way, make it larger, smaller, change it in a different way, and then take a model that's 3D printed and make a 1 to 2 part mold, and then use it, press mold or slip cast multiples. So the idea here is to create multiples. And I use for a sense of concept and a way of organizing the multiples, the Japanese forms of unity list and under forms of collection, and the list is on the screen, and they need to choose a very specific one of those. And they need to arrange like 6 to 12 of these in one of those arrangements. Slips, underglazes, glazes can be used to finish this particular piece appropriately, and they can use found objects and other materials in order to get their ideas across. So, for example, they might use rope to do a bundling form of collection. I asked them not to share their particular one that they choose, so that at our critiques we actually do a guessing game and see if we could come pretty close to those. And probably the most interesting one that's up on that screen is the chicken wings. So I actually had a student scan chicken wings in the library. Luckily, our librarian is also a ceramics artist, and so she came into the smell of chicken wings one morning and laughed about it, so that was good. A few other examples. Whoops, one too many here. Here we go. Oops. Here are some examples, 3D scanned printed models. Lots of them involve then laser cutting, for example, to make boxes, silk screen to create other patterns and designs that go along with their particular projects. And for that 2D, 3D class, then I usually have a self-directed project at the very end, asking them to combine some of these techniques. And clay only needs to be a third of the project. It can be more, it can be pre-manufactured or handmade or a combination of the two. And they have to involve a couple techniques and at least one of them that they haven't used before. And this particular case, the student created these little kind of tray-like stands and had them printed in the Z-Corp printer, created their own homemade slime, had a ceramic funnel that hung and draped and poured onto these 3D images. And of course, some of the techniques that they have available to them are, besides, of course, the decal work that they've already had, is laser cutting, water jet cutting, silk screening, scanning and printing, and CNC routing. And some more examples, and most of these involved some 3D printing and or some laser cutting as well. And in order to prepare our ceramic graduate students for a career that will require them to work collaboratively with others, I assigned this particular project to them in grad seminar. The design thinking technique, with its focus on problem solving in a collaborative setting, was used to design work, create a prototype, and carry out its low volume production. The assignment was to work as a team involving other disciplines and engineering, architecture, food industry, business, PR, etc., to design a product. Many design resources and current industrial practices are covered. IDEO, the design thinking firm, and their concept of design thinking, their concept of design thinking is a major influence in the process and product. They worked with 4 people on the team, and I mixed that into a kind of a group where they had different skills and could work together. They also had to include someone from outside of the class, and this particular group worked with a restaurant in town and also checked in with supermarkets, etc. Here you can see they call their team the Lunch Bunch. I think I have a better, there's a better image of that. Their problem is to solve how to stop waste from takeout containers and replace them with an attractive and functional reusable ceramic box. After brainstorming and drawing, they made some rough clay prototypes. They did try using some 3D modeling techniques, but found that the clay made a best final prototype. And some of that was limitations in terms of use of 3D modeling, but one of the points here I would say is that the 3D modeling doesn't always have to end up having a final product. It can just be used for ideation. And then they used the laser cutter to cut a food-safe plexiglass lid for that particular box. And here you could kind of see them in action. There's a coating, basically it's tool dip on the bottom. You can change colors with the tool dip. That keeps the box from slipping and also from banging clay against clay, as they were also designed so that they can stack. You can see the team names on the top that work together on this. And of course, if there was continuation with this particular project, of course, this pretty much took up our semester. The logical next step here would be how to make this a reasonably priced object, and how would restaurants actually put it into practical use. Now, our students don't have quite the integrated available technology that you'll see with Chad's program. We have a Fab Lab that is very well equipped. It is a few blocks away. It's in an innovation dorm. We established it about 10 years ago in partnership with architecture, and it was originally funded by the Office of Research. It now has to generate its funding through fees. It has expanded considerably, which is not an ideal situation, but it does offer some very high-end technology, not easily found in smaller settings. And so some of the things available to our students in regards to 3D printing is an object resin printer, which is a very high-end resin printer, a Z-Core powder printer, MakerBots, and Fusion FDM or filament printers. Well, this is moving along by itself, I'm afraid to say, so there's some weird thing, I'm sorry to say on the, here we go, on the, because I'm purposefully keeping my thumb up here. There's 4 laser cutters and a variety of types and sizes, as well as a large bed, CNC router, and water jet cutter. One of the trends that's happening now, and that we've been noticing, some of you probably have seen that university libraries are serving the needs of students in this arena. Our science library, this is just a corner of their 3D printing center. They have mostly MakerBot replicators and Fusion 3D printers. You order a print online, upload a file. A few days later, you go to the library desk where you check out books, and they will have a print waiting for you to take home. Fees are very reasonable, and they also have Next Engine scanners available for use, as well as the library that we have upstairs from us. I did want to include some other people working in this particular vein, and here's one person, Nagumi Natoa. I hope I'm saying that correctly. She teaches at Emmanuel College. It's a small liberal arts college located in Boston, and she teaches a class that services what's called aesthetic inquiry for all the art majors. She has a MakerBot and a Delta Clay printer handy, and she worked with the student Keith Becker and experimented in the summer of 2016 to work collaboratively on this particular project. She was in her studio in the UK, and her student was working in the Emmanuel studio in Boston. And they call this collabware. It's designed to showcase and promote student work. The products are sold to raise funds for art student scholarships. And they only communicated through like Messenger, Skype, etc. in order to get this particular project done. They'd share 3D files. And so they were able to do something that was precise and eliminated the requirement of collaborating artists working in the same studio. And she mentions that this particular summer project is featured in Studio Potter magazine. Jeremy Brooks teaches at SIU Carbondale, and he describes this particular assignment. He uses an app that's on your iPhone, basically, called Let's Create Pottery. And it essentially allows one to 3D model a pot on the wheel using an iPad or iPhone, and it's kind of an entertainment app, and it's by no means a modeling program like Rhino, he states. He has the students design a pot, and afterwards they're told, so they're not told ahead of time, afterwards they're told to make the pot they designed in the app. And so this is kind of almost like a back end way to get them used to working with 3D technologies. I thought this was an extremely clever and tricky way to get them to think in this way. So these are some of his examples. Shyla Marsh is a postgraduate assistant in residence at the University of West Virginia Ceramics Technology and Production Center. She's teaching a course called 3D Printing for Making Tools, and here are some images of 3D printed stamps from that class. She is in the Fab Lab across the way, so be sure to go in and check on what she's been up to. Nick Tomasic, and I'm proud to say he's a former student during my time when I taught at KSU, is presently teaching at Blue Valley West High School, Overland Park in suburban Kansas City. He teaches 9th, 10th, 11th, and 12th graders, and he describes the use of technology. The 3D printed texture rollers have been most popular with my students. They have used the rollers designed by my colleagues and I in Joe Cam's class, and at this very moment I think he's demonstrating how to make these in the Fab Lab, so please be sure to go check out what Joe Cam is doing as well. He also uses plaster molds that have been created out of 3D printed objects and then slip cast. So even at the high school level, you'll see that the students that will be coming to us in universities are going to be coming with a lot of this experience and knowledge, and we definitely need to be ready for them. Also over at the Fab Lab is Kelly O'Brien. She describes this project that was done while she was at the University of West Virginia. Currently, she's assistant professor at the University of Dallas. She states that these are images from the digital ceramics class she taught there. They made a prototype for the production line, which needed to be something out of the round. This is the prototype designed in Maya. You can see that on the top there, and the prototype, and then the ram press mold was made from there, and this is kind of a handmade ram press that they have available there, and some examples of the finished bowl. Oh, this is jumping ahead, isn't it? All right, here we go. So now back to UF, a couple more examples. This is by Eddie Dominguez. He has his BFA in ceramics and was involved in our university scholars program and worked with me as his mentor. He combined his knowledge of 3D modeling with the Peter Pincus mold making workshop. He developed a method to print the sectional plastic molds to cast the plastic molds for his pieces. The design is scanned from model cars and repeated in Maya. And here you'll see a cup that is slip cast. I'm sorry this is jumping around. I don't seem to have any control over where it's going. It worked when we tried it out the other day, didn't it? Alrighty. I've also been doing some work with PC Substrate. That's also available from Ceramic Art Cart. I use it for light boxes primarily. This material is a fully vitrified ceramic substrate, highly translucent, incredibly strong, and beautifully smooth, as their website claims. Is there some way to stop the timer from running along here? It is suitable for a wide range of applications. It's very hard, alumina-based material, needs to be cut on a water jet. UF grad Karen Sankis has also been working with it, and she's using decals and incorporating it alongside other traditional ceramic materials. UF does actually encourage this sort of interdisciplinary work, and so there was a competitive grant that I received which allowed me some release time and research funding to work with materials engineer and ceramics 3D printing materials. As part of my grant, we organized a symposium, 3D Printing with STEAM, which is a takeoff on the STEM, which is, of course, overtaking our country, with the A for art in it as well. Dwayne Bray, who's the vice president of IDEO, came as a keynote speaker and helped to facilitate a design thinking activity in terms of how we are, how to use some of this 3D technology in our work. Our speakers came from art, neuroscience, mechanical engineering, anthropology, and all other fields. And they were talking about how they use 3D printing in their various fields. What also resulted was research on improving materials for ceramic 3D printers. Students from ceramics and engineering printed together and worked together. A student from materials engineering, Andrew Pertu, was part of this team. The overall goal of his project was to 3D print effective gas filters from a ceramic material called zeolite. This process involves a sequence of steps, including the modeling design of the filter, formulation, and a production of what engineers call a paste, we would call clay or slip, the configuration of the 3D printer for this particular paste, and then its printing. And then finally it was tested, and it actually did absorb CO2. So his working on this extremely tiny scale and accuracy was, of course, interesting for us as artists to watch develop. So we learned a lot about some new ceramic materials by working with him, and the engineers learned a lot about clay properties that can be extruded, and we're continuing to do some of this work. Here's our little research lab, which is otherwise known as my office. Derek Revert's our teaching lab specialist, and I hold weekly printing sessions. Sessions often end up with results like this, and I try to remind myself that I can have a similar thing happen on the wheel when a cup kind of falls over. The Power of Making, The Importance of Being Skilled is a book sponsored by a collaboration between the Victoria and Albert Museum and the Crafts Council in England. And in one particular chapter by Ellie Carpenter, she addresses the issue of de-skilling through the current proliferation of the DIY movement. She finds this movement uses both old and new technologies and any tools or materials needed to make. She states, this approach acknowledges digital making as craft, as discussed by Richard Sennett in his book, The Craftsman. Sennett argues that the open source operating system Linux, for example, is a public craft because it's a tool that actively shapes the world around us through collective making. She goes on to say, embracing digital making as a craft enables space for experimentation and collaborative production, as well as in-depth understanding of how things work and how to build and repair them. I have to admit it's not easy to motivate students to use these technologies. I believe the software is intimidating. Access is always an issue. We continue to struggle with the new slicer software used to create the G-code from the 3D files in order to allow these files to actually print. We recently invested in a 3D Potter bot, as it's easier to use than the Delta Wasp that we've had now for over a year, where air pressure from a compressor becomes another factor in getting prints to print. So besides that, there's always clay quality, speed, shape, scale. They all come into play when trying to print clay directly. When it does work, we have a really happy session. So I want to thank you for your interest and attention, and then I'm going to hand this over to my colleague here, Chad Curtis, so he could show you what's happening at Temple University, and then we'll take questions at the end. Thank you very much.
So a quick note of thanks to you, Anna, for motivating us to put this together and proposing this. One of the interesting things about this process has been comparing notes. And so obviously this is happening at a lot of universities. But the way it happens and why it happens and how it happens seems to be slightly different in each instance based on any number of factors. So you'll hear me probably repeat some of the things Anna said, but in other cases we have stark differences as well as to how we're implementing these things and why and so on. So in terms of rationale, I'm going to echo Anna in that one of the primary motivations has been to increase accessibility to the ceramics medium to a wider range of students. When I started doing this work about 8-9 years ago and was giving tours to prospective students, one of the first things parents would say is, what will my child do with a degree in ceramics? And one of my answers has become, we're integrating these technologies alongside traditional hand skills. And there's a great deal of value in traditional hand skills, and so it's not to downplay that in any way. But at the same time, we also have another set of tools available that students need to have an understanding of. And if they can think holistically across a variety of these of these materials and boundaries and processes, it allows them to problem solve at a much higher level. And so whether they remain in the field or not, as they move ahead in their career, they can apply these problem solving skills in multiple ways and be more successful in the job market. And that's an example as well as we think about the rising cost of tuition. You know, what is our social responsibility to our students in terms of preparing them for a life after school? So that's happened in a number of ways that I'm going to come back to. The slide that you're seeing now is a class I taught called Making Through Algorithms, and I'm going to come back to that in a minute. But that was a collaborative class that I taught, and from this standpoint, ceramics can be hard to argue for in a research university. Temple's a research university. It's driven by research, and in the higher administration, they're often wondering, you know, what relevancy does ceramics have? And it's a reality we face. And so talking about collaboration, integration of technology, and higher order problem-solving skills is a way to speak the language of administration. And again, it's not intended to devalue what we do in clay, but it's the way to speak the language and communicate the value in what it is we do. And so at Temple and myself, I'm really committed to giving students a skill set and an education that's transferable. And you know, we all hope that they stay and they work as artists and they work in clay, but the reality is a lot of them will not. And what value does their education have if they do not? And it's thinking through those possibilities. How can we provide more in an education and be responsible citizens as educators that gives them a skill set to make them have the best potential to be successful upon graduation as possible. And it's also a way in which we can be much more inclusive for who comes through our front doors. And so, you know, we think about inclusive teaching environments and accessing audiences that from a wider range of socioeconomic backgrounds. Let's face it, a lot of students go into graphic design because they can get a job with that. And if I can capitalize on that audience and bring that audience into ceramics, I introduce them to a new medium, I extend a material to them that they would likely not have access to or interested in otherwise, and the technology becomes a bridge to a new population that I wouldn't get through my front door otherwise. That is a benefit to those students who maybe sit in front of a computer all day. They get a material knowledge they're not necessarily getting working digitally. It also helps my numbers in my program and keeps me strong within the university and sustains the program for the majors that are there to work in clay. So, you know, it has a win-win situation back and forth both ways. So I'll talk a little bit about some of the teaching methods that I'm using. They've evolved over the past 8 years. Initially, I was teaching a 3D design class, digital design class, and we were printing with a MakerBot, and that was really cumbersome and slow. And so as a result of that, arrived at some new strategies that are a bit quicker and also based upon my knowledge of both what is successful as a teacher, but also what the students are interested in. So one of the things we've done was to create a direct and simple process with a laser cutter. And so we developed, as you can see in the slide, a process for making a laser cut stencil in 10 minutes or less. And that's simply the students taking a white piece of paper and a black Sharpie and making a drawing or perhaps an image. They import it into Illustrator, use Live Trace to convert that into a path, and then we go to the laser cutter and cut a stencil from that. And once that stencil is cut out of just simple newsprint paper, it can be wetted, attached to greenware, and then painted over with slip, so it becomes basically a resist process. Painted over and used to create more complex imagery. And it opens the door in the same way that a decal printer opens the door to another audience of students. Anybody that can hit print on the computer can create a ceramic decal, and that's fabulous. But here's a way in which a student that is more 2D oriented, is interested in drawing, can take those skills, bring them into digital space, produce a stencil, and then apply that directly to their greenware and paint over that to reproduce an image. And it's a low stakes, low barrier strategy to introduce students to this technology that's really simple and effective. So here's an example of that being applied by one of our former undergraduates, PJ Hargraves. where he used this stencil process to recreate some images of some well-known basketball players from the 80s and apply them directly to plates. Another space that I've integrated this is working with tiles. And so Anna was talking about working from 2D to 3D, and that's a pretty common strategy in the digital kind of space. So here what you're seeing is an image from Rhino, a software tool, and there's a pattern that's laid out there, kind of a fish scale scalloped pattern that's laid out two-dimensionally, and then sitting on top of that is a 3D mold that is made from that pattern. So in this slide, you can see what that pattern looks like when it's turned into a positive, and then the mold's still sitting there. And then ultimately what we do is bring that to the CNC machine and mill that mold directly in plaster. So it cuts out the whole process of making a positive, and we go right to generating the mold that a student then can cast or press into. And it's a very direct and quick process. And as Anna was saying, the sooner you can get a student to a tangible result that they can see and touch and understand the process comprehensively, the more likely they are to sustain working in that way. And so generally I can get students to this point where we're milling in about 3 weeks. Doesn't mean they're great modelers at that point, but they understand the process from start to finish. And with anything, once we understand what the process looks like from start to finish, we can begin to imagine new ways in which to use that. And so it's a quick way to do that and not get bogged down in the specific details. And I have to admit, the first couple times I taught digital technology and 3D modeling, we got bogged down for weeks and lost in the weeds with the software, trying to introduce every little detail. And we don't need that. That comes in time, in the same way that it comes in time with any other material. So my advice is to focus on quick, tangible results so that students can see how the process actually works and then begin to personalize it for their interests. So this is an image of the CNC, the mill at work. And so there's been a lot of talk about 3D printing, which is an additive process, just like coil building. It's building up of material. A CNC is a subtractive process, so you start with a block of material and take away material to produce a positive or a negative. But in our case, we're generally producing a negative to create a mold. So here's several molds from a class that have been milled and that are ready for casting. One of the advantages of the CNC process is it's just so much more robust than 3D printing. The machine operates faster, it breaks down less, it's less complicated, it's less finicky in terms of the file type. It gets to the results much more quickly. And here's some of the projects that have come out of that. So again, working with tiles, thinking about surface relief and repetition over a space. And I like to include this one. It's a bit more of an organic looking quality in terms of developing a tile. And so oftentimes we associate digital processes with rigidity and things being really tight and precise, and they can be. But it's also nice to see this kind of work happening where it's looser and softer and more organic in quality, compared to this, which is much tighter and much more geometric and almost in the, kind of the MC Escher kind of space. As I said, one of the classes I've taught collaboratively was a class called Making Through Algorithms, and it was a way in which for students to think about computer programming through tactile experience. So one of the things we did is we used crochet as a means for understanding a program. So, purl, or not in that case, I guess that would be knitting. Similar idea. But if you were to say knit 3 stitches and purl 1, knit 3 stitches and purl 1, that's a simple algorithm. It's a way in which to create something that is more expansive. And so we introduced that kind of thinking. In this class, we paired ceramic students with architecture students and asked them to create a tile cladding that could be used in an architectural kind of space. And so they worked from 2D to 3D in a similar manner that I was talking about. They laser cut, they sketched, they drew, but they also worked in teams. And one of the great things about working in teams is that no one person has to have the entire skill set, right? Much in the same way that they're probably going to work in their professional lives after school, they're going to be part of a team that contributes some set of skills, but probably not all of the skills. So they have to learn to communicate with one another. They have to learn to compromise, to negotiate, to trust in somebody else that they can design the thing that they're thinking about. And so in this way, my ceramic students maybe came to that with the technical knowledge about clay. The architecture students came to the technical knowledge about the digital side of things. And then collaboratively, they got to think about how that sits on an architectural kind of space. And so there's some great transferable skills that come out of a class like that. So what you see here are some of the results of that, where they prototyped small versions of these cladding systems that could, again, cover a wall or an outside space. They presented them as teams as well, so they had to talk about the design process, the methodology, the strategy behind it, and how they hoped it would function in the world. So there was, a direct kind of application process. One of the things I've learned in all these classes is that the amount of time I imagine it's going to take is never enough. It always takes longer, and things always get compressed at the end. So I started by including everything in the kitchen sink, and every time I teach it, I take away and I take away and I take away to try to simplify and get the students to a successful result more quickly, and recognize it's going to take longer than I think it's going to. So I want to spend just a few minutes talking about the impact on studio practice, because ultimately that's what this is about, is how do we implement this and use it in the studio. So one of the things I have done at Tyler is I've had the good fortune to be able to integrate this directly into ceramics. So Anna was saying that at University of Florida they have a Fab Lab, and for a long time I was lobbying for a Fab Lab and it wasn't happening. So I made it happen other ways, and in the end I think maybe arrived at a result that was better for my students. And that was to integrate this technology directly into the ceramic studio. So here we're looking at some computer workstations. They're sitting in the glaze lab, right alongside the dusty materials and the glaze mixing and everything else. Also in our glaze lab, we have that laser cutter. And this was a test in the school. We have multiple laser cutters in the school, and we put it in our space, and it's accessible and unsecured 24 hours a day. And the tech people said it's going to get destroyed, it's not going to work, it's going to break. And it's been in there for 3 years, and it's working fine. And nobody's broken it. Minor issues. But I think the trade-off of having it accessible and an integrated part of the studio practice far outweighs the risk that the students are going to do something that's dangerous or they're going to break it. So we also have a CNC router directly in the clay studio. Now that one is locked up because that one has the potential for a lot more physical harm than a laser cutter does. But it's right adjacent to our kiln room. It's right in the physical working space. And that has allowed students to use it in a way that has direct integration and impact into their studio practice. So it doesn't become this novelty that sits somewhere else, that's controlled by someone else, and has a lot of proprietary layers to it. I think the more that we can break down those things and put it in the hands of our students, they can use it like they use any other tool, like the slab roller, the potter's wheel, what have you, and innovate in ways that are interesting as opposed to novelty. Novelty wears off really quickly. So again, I recognize not every program can do that, and I've been lucky to be able to do that. But at the same time, the cost of this equipment continues to drop. And so I think more and more this will be a possibility for programs to do this, to think about, do we have one Fab Lab, or do we locate these tools where they're needed directly in the student space so they can use it as an art-making tool and not as this specialty process? So an example of the way this changes the way in students work is Juan Hurtado Salazar. Juan is an undergraduate ceramics student. He took my digital class last fall. We worked through that in terms of clay, but then he started to apply it to other things. He said, well, I want to make a sculpture. So Juan's a DACA student. He has other family members that are in the States that are also undocumented. He has a nephew that he's thinking about his future. And so he decided to make a monument to his nephew. And in this case, he scanned his nephew. Anna was talking about digital scanning technology. Scanned his nephew and made a styrofoam working prototype of a monument that he would like to produce in his honor. So this is about 12 feet tall. And here's a perfect example of where skills are transferable. So it's introduced in one context with one material and one process, and it's applied in another context. And I think the more that we can do that, the more successful our students can be as they move out into their professional lives. Tyler Schrant is an current MFA student, and Tyler came in with an interest in some digital technologies and was utilizing a lot of our resources, but we collectively, and Tyler in particular, were interested in thinking about printing directly in clay. And like Anna, we had built a Delta 3D printer, and it was finicky and had some issues, but interesting. So this is a shot of Tyler's studio, and we ended up putting together a clay 3D printer for about $1,000. And it's cobbled together from a 3D printer from Amazon that was designed to print plastic, and we attached a wasp extruder to it, and for about $1,000 had a tool that is quite capable. And I think Tyler's sitting in the room, but I think it was a great learning process for him as well. And he now has the inside and working knowledge of how that tool functions. So again, rather than being beholden to, this is the technology and it works in this way, and it's designed by a large corporation, you can't change the outcome, Tyler has the working knowledge to change the outcome in any given way that he wants to. So it becomes his tool that can be manipulated and make work that's particular to him. Another example, Ruhi Kim. Ruhi is was a metals and jewelry MFA student, and she just took a digital class with me, an independent study, and she incorporated those larger forms that you're seeing there were milled molds, and they're cast in porcelain. It's unglazed porcelain. And then the other elements there are 3D printed nylon and sterling silver. So she was able to combine multiple skill sets and multiple materials into a much more complex and elaborate form. And in this case, she had the digital skills, we had the equipment. Her knowledge that she needed was the clay side of things. And so I was able to introduce her to mold making and slip casting technology, and then she, holistically integrated those things quite well. I mentioned another class that I've taught is a class that was this past fall called Design, Function, and Production. And I received an entrepreneurial fellowship from the Fox School of Business at Temple to design a class that would help develop students' entrepreneurial skills. And so the digital technology was a really great place to do that and to think about, as Anna was saying, introducing ideas of design thinking, design in terms of form and function, and then ultimately, how does one produce that, and how does it live in the world, and what are the economics of that? So oftentimes, we make things in the arts that aren't economically viable because of whatever, any number of reasons, but oftentimes the labor involved. And so one of the criteria of this class was to make an object that could be produced at a low enough cost that it could go out in the world and be a consumable object. And this really was from a kind of design approach. So this student, Dan Meyer, is an MFA student in glass, and he milled a carbon blow mold. And it's a quite beautiful object in and of itself. But ultimately what he produced from that were these really beautiful champagne flutes that he blew into, added stems to, and then part of the outcome of this class was the students had to design laser cut packaging that it would be packed and sold in. So thinking about the process from start to finish. And one of the things I've really wanted the students to be able to walk away from is the idea that they could be a small scale manufacturer, from the designer to the producer to the marketer, with a very limited amount of overhead in their professional lives if they so choose. So we think about the idea of maybe going back to the 60s and 70s of the country potter, right? Having a self-contained business. And that's a beautiful lifestyle if it works. But this is a contemporary version that allows another alternative of a similar idea. And it puts the power of the entrepreneurship back in the hands of the individual as opposed to located in a larger company or corporation. And from that place, I think there's a lot of value in that kind of thinking and ideology. So just a couple of thoughts as I conclude that I want to leave you with. So first of all, whatever it is that you're doing, make it accessible and approachable. And I mean that both in terms of what we do with our students, but for those of you that are in the room that maybe teach and these skills are new to you, you don't have to know everything, and it doesn't have to be complicated. You can simply figure out a process and a strategy that is simple and works with your level of expertise, your available tools, your available skill set, and implement it and see what happens. And like any other process, your teaching, your knowledge, and your skill set will grow from that. And in time, probably become more elaborate. But initially, it doesn't need to be. So to get over, both for us as educators, but also for our students, that hurdle of, oh my God, it's technology, what do I do with it? But to just simply dive in and make it accessible. As we've both said, it's easy to get lost in the details of the software, of the process, of, oh, that didn't quite print how I wanted it to, I'm going to do it again. And I would argue that, create a short timeline for tangible results and utilize those things. And then focus on the overall process, the conceptualization of how does this work from start to finish, versus developing elaborate design skills. That will, again, those will come in time. If a student's interested, once they understand how things work, they'll develop that and they'll take it places hopefully that we can't imagine as educators, and that's fantastic. That's their job. So we give them the skills and they elaborate it from that. But we really, especially I think with what I see with ceramic students, is they come to ceramics because they want tactility, they want to touch things, they want to make things. And if they're not able to get to that place pretty quickly with the digital technology, they've lost interest. So the sooner we can do that, the better. I really think it's important that we encourage students to integrate this as part of their practice, to not see it as something separate, to not see it as something that has a huge novelty factor, but to integrate it with all of our traditional studio processes. I think in that way, the students have the ability to make the work that's most personable to them, but also the strongest in terms of communicating what it is they want to in the world and how that functions, as opposed to having it be stuck in that place of novelty. It's really tough to compete with novelty. We all know that, and we see that in the marketplace all the time. So that integration piece is huge. Finally, I think it's really important to encourage students to use technology as a means to cross material and disciplinary boundaries. I think it's important for our students to have that ability. I think it's important for us as educators to use that as a strategy to advocate for our programs, to advocate for how we're relevant in a student's education and in a larger entrepreneurial and career-oriented relationship to what happens after they graduate. Those transferable skills are really key. And ultimately, if nothing else, I think by introducing digital technology, we introduce a new strategy for thinking and a new methodology for problem solving. And one of the things I've always loved about clay is the problem solving aspect. Something happened, I don't know how to fix it, what's going on, right? And those are the kind of skills that happen in technology, they happen in all aspects of our lives. And I think the more that we can understand that those are skill sets that are valuable in the workforce, regardless of what it is we do, the better that we're doing as educators in preparing our students and having value for the education that they're paying for. So with that, I will say thank you. And Anne and I are open to questions.
Just ask you to go to the mic, please. Are we on? Can you hear me? Oh, there we go. Okay, I guess we had to get this a little closer. But yes, if you have any questions, please please send them along here from the mic.
Hi.
Hi.
I have a question about how, thank you, that was fascinating. I teach at a very small school, and we might not have the means or the faculty to, or even the student body to operate this sort of equipment at a scale like Florida and Tyler. Do you have any advice about how this sort of information might transfer to a smaller liberal arts college setting where there might be 1 or 2 faculty members in ceramics and a very small sculpture program and no glass program?
A couple of the examples I showed are people that are coming from smaller programs. So there are some of those going. The reason we even got our Fab Lab because we were willing to collaborate and there was money for collaboration. So one of the things I would recommend is talk to the people at the library. As a matter of fact, the woman who's running the technology in our library system that has this, like, I don't know, 20 or 30 3D printers in our library, she's actually written a book about some of that. So there's some people out there with resources, and I would try to make some connections. You'll also find that engineering, like our engineering college, they have a bunch of different areas already with different types of 3D printers, and they're often looking for people to do the STEAM thing. Many grants that they apply for, the science people, have to have some sort of extension or collaboration elements, and so you might be able to do that in terms of teamwork. And then the other thing is, I would just keep it really simple. We had like a solid doodle printer kind of thing to start out with in the studio. I mean, like really basic, a few $100s worth of a printer that was easy to run. I would require the students to have to sit and watch their print being printed, because if one thing went wrong, the whole thing would just practically blow up. So I would start small, and I would look for collaborators, because there's probably a lot of printers. Part of that Catalyst grant I received, I spent a good part of the one semester checking with people all over the university to see who was doing 3D printing, and I was surprised how many people were doing it in some very obscure places that you would never expect, and there might be ways for you to be able to connect and collaborate with some of those. So those are a couple of different ways. Start small. One little printer gets people excited about it. You could then start to argue for something maybe a little bigger and better. And then to also see, because there's probably a bunch of stuff already happening that you don't even know about, because I was shocked at the amount of stuff going on.
And I would say maybe let the students take the lead. So there might be opportunities for undergraduate research grants, that sort of thing that a student can apply for. And as I was saying, in our case, the 3D printer that we're using at the moment that prints clay, we put together from 2 basic components for about $1,000. And for a student that's motivated, I think that's well within reach to understand the knowledge base required to do that. And so if the school or university can provide a little bit of resources to help them get there, and let the students be the proponent of that, and if the students are the one asking for it, oftentimes they're better advocates than we can be as faculty. So that might be another approach.
How many people are doing 3D printing in their programs? So that's a resource. I mean, this has been great to be able to work with Chad, because so often I feel like I'm working in a vacuum. I actually went up to visit Brian Sibas up in New Paltz. I managed to get some grant money because I just had to talk to somebody else that was doing this, and I found out that sometimes things fail for him too. And here's the man who goes around the country building these and doing workshops. So trying to connect with some other people doing it has been really, really helpful. Because otherwise you can feel pretty isolated and just not have the resources that you need. There's not a lot of textbooks. There's a lot of textbooks on how to throw on the wheel, how to do glazes, but there's not a whole lot about printing with clay.
I think the other thing, I know there's some K-12 educators in the room as well, and certainly this is starting to happen in K-12 education as well. So I think more and more we're going to see our students coming prepped with a certain skill set, or at least a certain conceptual understanding of what the tools can do. And as a result of that, they're going to be much more adept at integrating these things than those of us that are coming to them later in life ultimately are.
If you don't mind going to the mic, I'm sorry. They're trying to record all this. Thank you.
I didn't have a question. I just had a comment.
That's good.
I know that Clemson University works with the architecture department, and there's been some really good cross-pollination there, where they've worked together with some of the 3D, hi Jerry, the 3D technology.
Yeah, that's exactly what's happening. That lots of times these things are happening. we're just starting to work with this, but the engineering department got SLA printers. Those are the ones that it's like a liquid bath, and there's lasers that harden the material, and then you just kind of pull up your 3D print, so there's not a support system required with rafting, etc. So if you do a little digging, you'll often find out that some other areas are doing some of these sorts of things. And our Fab Lab, like I said, would not have happened if we hadn't collaborated with architecture.
The other thing I think that we can do with this that is sort of what Jeremy Brooks is doing is that we can, if you don't have the tools to actually output these processes, but if the students understand how the tools function and some of the strategies they use for construction, that those can be applied in a hand-based or an analog manner. So they understand the digital process, but then come back and actually execute it by hand in the same way that the digital process would work, if that makes sense. So for instance, if we think about like layering strategies, we all understand coil building, so that's one strategy. But a lot of these softwares develop models by what are called waffle models, which are just crossing planes in space that represent a 3D form. So if a student can model something digitally, turn it into a waffle model, and then hand build that, right, it introduces them conceptually to the process, and when they then in fact do have access to the tools, they're ready to go in terms of implementation. And it also bridges that gap from, you know, analog to digital and back to analog. And I think the more that we can, again, blur those boundaries and not have them be distinctly separate things, the more complex and interesting things become, and the more complex the material language and the formal language becomes.
Thank you very much.